Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU actuary. Here's a problem for today for exam P on probability. You are given that the random variable x is uniformly distributed on the interval from 0 to 1, and that the conditional distribution of another random variable y, given that x is equal to x, is uniform on the interval from 0 to x. Find the correlation coefficient of these two random variables. And here's the solution. So we know that e of x is 1/2 and variance of x is 1/12, because x is uniform on the interval from 0 to 1. Remember, for the exam P, you must remember the mean and variance of a uniform distribution, one-dimensional uniform distribution. The mean is the midpoint where the distribution is uniform, of the interval where the distribution is uniform, and the variance is the square of the length of that interval divided by 12. In this case, it's 1 minus 0 squared, which is 1 divided by 12. But we also need to find the mean and variance of y and the covariance of x and y. Well, okay. E of y, it's the integral from 0 to 1 for all values of x, of the integral from 0 to x for all values of y times the joint density of x and y, dy dx. So it's the integral from 0 to 1 of the integral from 0 to x of y times f sub y of y given x times f sub x of x dy dx. That's equal to the integral from 0 to 1 of the integral from 0 to x of y times the conditional density of y given x is 1 over x, because it's uniform distribution from 0 to x. And f sub x of x is 1, because it's uniform distribution from 0 to 1. Okay, so that's equal to the integral from 0 to 1 of the integral from 0 to x of y over x dy and dx. Well, 1 over x is not a function of y, so we can put it in front of the integral and inside. So this becomes the integral from 0 to 1 of 1 over x times the integral from 0 to x of y dx, y dy dx. So the integral from 0 to 1 of 1 over x of 1/2 y squared evaluated from 0 to x dx. So that's 1/2 x squared times 1 over x, which is 1/2 x. So we have the integral from 0 to 1 of 1/2 x, which is x squared over 4 evaluated from 0 to 1, and that's 1/4. The second moment of y is the same type of integral, but of y squared, so we do all the same things. And we end up with integral from 0 to 1 of 1 over x, of the integral from 0 to x of y squared dy dx. Of course, that's 1/3 y cubed evaluated from 0 to x. So we end up with the integral from 0 to 1 of x squared over 3. That's x cubed over 9 evaluated from 0 to 1, and that's 1/9. So that the variance of y is e of y squared minus, I had a typo there, I had e of t. I apologize, it's e of y, the mean of y squared, and it's 1/9 minus 1/4 squared, that's 1/9 minus 1/16, so a common denominator is 144, so 16 minus 9 over 144, and that's 7 over 144. Furthermore, e of xy is the integral from 0 to 1 of the integral from 0 to x of xy times the joint density, which is the integral from 0 to 1 of the integral from 0 to x of xy times f sub y of y given x times f sub x of x dy dx. And then that becomes the integral from 0 to 1 of the integral from 0 to x of xy times 1 over x times 1 dy dx. Well, okay. x cancels, so this just becomes integral from 0 to 1 of the integral from 0 to x of y dy dx. That's integral from 0 to 1 of 1 half y squared evaluated from 0 to x dx. So the integral from 0 to 1 of x squared over 2 dx. That's x cubed over 6 evaluated from 0 to 1, and it's 1/6. And the correlation coefficient is the covariance over the product of the standard deviations of x and y, which is e of xy minus e of x times e of y over the product of standard deviations of x and y. And that's 1/6 minus 1 half times 1/4 divided by the square root of 112 times the square root of 7 over 144. That's 1/6 minus 1/8 over square root of 7 over square root of 12 times 112. 1 over 144, the square root of that is 1 over 12. So that's how we got that. And then 7 is basically moved to the other square root together with 12. Okay. Then we can take that 112, flip it over and move it to the numerator, and that becomes 12 over 6 minus 12 over 8 over square root of 7 divided by square root of 12. So 2 minus 1.5 over square root of 7 divided by 2 square roots of 3, because 12 is equal to 4 times 3. So that's 0.5 over square root of 7 over 2 square roots of 3. But of course that 1 half effectively in the denominator can be flipped and become 2 in the numerator. So 2 times 0.5 over square root of 7 divided by square root of 3. So this is equal to square root of 3 over square root of 7. That's answer C. Please remember this is copyrighted material. The problem comes from me and the solution is mine. Good luck in your studies and good luck on the test.